previously saw how to add intervals when we do not care about chromaticism, if you remember. We also learned how to multiply them. For example, we treated all thirds the same whether they were diminished, major, or augmented. How do we add intervals when we are distinguishing between the types of intervals? How do we add an augmented interval to a diminished interval, etc.? Now, we use the flat symbol in front of the interval to signify diminished. You might have seen that just now. We add a sharp symbol in front to symbolize augmented. I think that's not very surprising notation. The flat symbol. It's well. Anyway, it's not surprising notation. Okay, so let's go over some properties that will come in handy when we need to add intervals. First off, diminished cancels out augmented and vice versa. As long as you have the same number of diminished and augmented symbols, they cancel out. It looks like a mess, but you could cancel it out. They cancel out if they have the same number. So, an augmented negative interval is a negative diminished interval. That's one property. That's another property. An augmented negative interval is a negative diminished interval. Similarly, a diminished negative interval is a negative augmented interval. Augmenting a sum of intervals is adding the same intervals with one of them augmented. It doesn't matter which. Similarly, diminishing a sum of intervals is adding the same intervals with one of them diminished. Doesn't matter which. That means that when adding intervals, you can change which of the intervals is augmented. Similarly, you can swap which of the intervals is diminished. Now, these properties could be dubbed piano properties, since you can just look at the piano keyboard to read them off, as you can many other properties we talk about. For any interval, this is the first one. For any interval, diminishing the interval is subtracting a diminished second from the interval. We will need this later to multiply. Second property, for any interval, augmenting an interval is adding a diminished second to the interval. Now the third one, just accept that a diminished fourth is a third and a diminished eighth is a seventh. You could look at the keyboard, the white keys, if you go from E to F and B to C on the piano, the white keys that touch each other without any black keys in between, those notes, for instance, in the C major scale, they would be those notes, But anyway, for any other interval between a second and an eighth, other than the fourth and the eighth, the diminishing that interval is augmenting one minus that interval. Diminish eighth is augmented a minus first, however you want to say that. Example, a diminished fifth is augmenting 5 minus 1, interval, which is an augmented fourth. In our system, of course, a diminished seventh is an augmented sixth in the same way, but remember, a diminished fourth is not an augmented third. Of course, this is not true for some instruments, it's true for the piano. We're talking about the piano. That's why I said piano properties. And when we're adding augmented, diminished intervals and all that stuff, or modifying them, we're going to pretend we're dealing with a piano, the way things work on a piano. And the last two things, namely the diminished fourth is a third, and a diminished eighth is a seventh. And the other property for all the other intervals at a diminished eighth is augmented a minus 1. Those two properties are still true if you add a multiple of an octave. If you add a multiple of an octave, and it's easy to recognize multiples of an octave. They're always one larger than a multiple of 7. For instance, 15 is 14 plus 1, and 29 is 28 plus 1. 22nd is 21 plus 1. 50 is 49 plus 1. They're once, as long as and 49 is a multiple of 7, 14 is a multiple of 7, etc. You could recognize the octaves in that way, the multiples of an octave in that way. And if you add an octave to a fourth, then and you diminish what you get, remember you can distribute the diminished symbol. Then it will be exactly the same thing as what we said. You can see that because you could diminish the symbol. But anyway, okay. Yes, and finally, this is the last property. Finally, if we add any interval to a multiple of an octave, we don't need to worry about any other modifiers than the ones already present. The rules we already covered for adding intervals, when we reduce the smallest number and add what we then get. Remember the rule, you just look for the smallest number, you reduce it by 1, and you add the numbers normally. It always works if one of the two intervals you're adding is a multiple of an octave. It always works. You don't have to worry about whether the result's going to be diminished, whether it's going to be augmented and all that, unless you see a diminished or augmented symbol already present. They always work even if we care about chromaticism, whenever we're adding an interval to a multiple of an octave. And here's some examples of that. That doesn't mean, however, that we can now add the intervals at the beginning of this video. Even though we have a multiple of an octave in the 50th, as we just saw, we don't, because 50 is 49 plus 1, and 49 is a multiple of 7. We don't know how to subtract from an octave yet. We will get to finding out how to do that in the next video. We'll start, the process of finding out how to add any two intervals in the next video. And as usual, please remember to like and subscribe. Next time we'll start explaining how to add intervals when we care about chromaticism. See you next time.